going to look at some rate problems. Problem number 3, an aircraft carrier makes a trip to Guam and back. The trip there took 3 hours, and the return trip was 4 hours. If the average speed on the return trip was 6 kilometers per hour, I want to know what the average speed of the trip to Guam was. Okay, you'll notice it doesn't tell me how far away Guam is, but we have that information. So anyway, one thing that's good to do at the start of these problems is to list out the information that you know. One of the things you know here is you know that the original trip took 4 hours. The return trip, the original trip was 3 hours. The return trip was 4. So basically, we're going back and forth to this place. And so basically, the trip there took 3 hours. The trip back took 4 hours. And that 4 hours was done at 6 kilometers per hour. One of the things I suggest is using the equation distance equals rate times time to do these problems. And specifically, the organizational tool that I suggest doing is making a little chart. I make a distance, rate, time chart. Certainly there are other ways to do these problems, but I think this will make this pretty simple. First of all, the distance is the same for both. However, we weren't given that distance. So you always have to decide, is the value the same for both or is it different for both? Were you given that value or was it a variable? So I was not told the distance, but it's the same for both, going there and going back. So I'm going to call that variable D. I was given the two rates, or I was given, I was given the second rate. The second rate, if I can get my focus back here, the second rate was 6 kilometers per hour, so I'm going to put that in. And it also tells me that the trip there was 3 hours. The return trip was 4 hours. And I'm looking for this missing rate. So I should be able to set up equations pretty easily here. I know that distance is equal to rate times time. So my first equation is going to be D equals the rate of R times 3. I'm going to write that as 3R. The second equation, distance is equal to 6 times 4. And of course we're going to be able to find out that D is equal to 24. Substitute that back into my original equation. So I now have 24 equals 3R. We can divide both sides by 3, and we find out that the rate is equal to 8. And you really should include units on there. In this case, that is 8 kilometers per hour. And that's all you have to do. Now, if I want to try another example, good second example. Let's see if I can zoom out here and get it back on here. Question number 4. It says a cattle train left Miami and traveled toward New York. 14 hours later, a diesel train left, traveling at 45 kilometers per hour in an effort to catch up to the cattle train. After traveling for 4 hours, the diesel train finally caught up. I want to know what the average speed was for the cattle train. Now, once again, I can set up one of these distance, rate, and time graphs as you continue to look at number 4 here. So distance is equal to rate times time. I try to fill all of these in. Again, sometimes a picture can be useful here as well. Okay, so I've got the cattle train, which I'm going to represent on my paper with a C. I have the diesel train. And if you read the problem again, the trains are both traveling in the same direction. One's catching up with the other. So their distances are going to be the same. So I'm just going to call the distance D for both. It doesn't tell me anything else about their distances. It tells me that it does not tell me the time for either train. However, it says that one train left 14 hours after the other. So I'll do T, and I'll do T minus 14. It took 14 hours less. And Meanwhile, the second train, the diesel train, traveled at 45 kilometers per hour. And we want to find the average speed of the cattle train. Actually, I noticed something here. What I have here is wrong. I left out a fact. If we go back and look at this problem again, we'll see the fact that I've left out. Notice it says something about 14 hours later a train left. However, it actually does tell us that that diesel train traveled for 4 hours total. Okay, so that's the fast train. If it travels for 4 hours and the other train had traveled for 14 hours already, that time's actually going to be 18 hours for the original train. And then it's going to be 4 hours for that second train. We're looking for the average rate for the cattle train, so we'll fill that in. So again, I get two equations here. For the first equation, I get distance equals the rate times time, which is 18 times r. For the second equation, I get distance is equal to rate times time. That's 45 times 4. And notice once again, this is going to work out really nicely because I can take 45 times 4. It's 180. And so I can substitute that in for d in the original equation. 180 is going to be equal to 18r. And of course you can probably tell there that if you divide both sides by 18, you're going to find out that r is 10. Now again, you should evaluate what that means. In this case, it's the rate of the cattle train. That was traveling in kilometers per hour, so that would be 10 kilometers per hour. All right. So that's the basic idea for number 4 on this homework set. Okay. To take a look at another one. I'm going to look at number 10 this time. Number 10 says, if I can get it here, a passenger and a freight train start toward each other at the same time from positions 300 miles apart. If the rate of the passenger train exceeds the rate of the freight train by 15 miles per hour and they meet after 4 hours, what is the rate of each? Okay, so again, I'm told a few things, I'm not told a few things. Let's go over here and write down some stuff here. Okay, I'm going to do my distance, rate, and time chart. Okay, in the first case, the distance says that they're 300 miles apart. Okay, now this time they're going toward each other. Okay, and so this is the case where you may want to have a picture. 300 miles. One goes this way, one goes this way. It says that one is going at a rate of 15 miles per hour more than the other. So we'll do R. Actually, the freight train is going slower, so I'm going to call the freight train R, and I'm going to call R plus 15 the rate of the passenger train. It says that they meet after 4 hours. So it takes 4 hours for the two trains together to travel this 300 miles. Okay? So first of all, the distances are not necessarily the same. In fact, they're probably not. One's traveling faster than the other. So I can call the first distance D because it's unknown. But I need to subtract that from 300 to find out how far the other train went, because the two values should add up to 300. Now if we go back to the rates, we said the faster train is the R plus 15, and the slower one I just called R. And as far as time goes, it says that they meet after 4 hours, so they're both driving for that whole 4 hours. So once again, I should be able to write an equation here. For the first one, D is equal to, it'll be 4 times R plus 15. In the second equation, we're going to have 300 minus D equals 4R. And we can do a substitution here. We can do all kinds of things. I think I'm going to solve this equation here, 4D, and I'll just replace it in the other equation. So let's see, I can subtract 300 from both sides. That's going to be negative D equals 4R minus 300. I'm going to divide both sides by negative 1. I find out that D is equal to 300 minus 4R. Now I can substitute that into my original equation. So 300 minus 4r is going to be equal to 4r plus 60 when I use when I use the distributive property to multiply out my parentheses there. I can add 4r to both sides there. I'm going to have 8r on that side. I can subtract 60 from both sides. I get 240 is equal to 8r. Divide both sides by 8, and I find out that r is equal to 30. All right, remember what that is. That's 30 miles per hour, and that's one of my rates. That's my slower rate. Okay, if you go back to the original problem, you notice there are two rates here. There's the slow one and there's the fast one. So I have 30, and technically it's 30 miles per hour and 45 miles per hour. And you can use that. And of course, you can also use those rates. You can go back and substitute, and you can solve for the distances that they are apart. Oh, well, we know the distance apart that they are already anyway, so never mind. The rates are going to be all we need in this case.